All right, we are going to do question 14. There's would like you to watch till the end. I think this is a good one to think about, actually, because I think there's a mistake that some people will make with this question. So there are a school offering subjects: 6 Group A, 8 Group B, 5 Group B subjects. Kristen has to study 2 Group A, 2 Group B, 1 Group C, and then she gets a 6th subject choice. Can come from any group. So I'm going to try and make some notes here about this. All right, and it's question 14, I believe. We've got Group A. Group A, GP for group. There's 6 subjects to choose from. Group B, there was 8 to choose from. Group C, 5 to choose from. She's got to choose 6. 1, 2, 3, 4, 5, 6. They've got to come from A, the first 2. The second 2 have to come from B. This one here has to come from C. And then here she can choose A, B, or C. Okay, now we actually have to do this in 3 steps. We have to say, let's make that last choice a Group A. So if she did 3 A's, or if that last choice was a B, I'll explain to you why we have to do it this way at the end of the video. Or we could have 2 C's here, right? 2 C's. If we had 3 A's, right, then we've got an A. You're choosing 3 A's out of 6. So you've got 6, choose 3. Then you go to your B's, you've got 8, choose 2. When you get to your C's, you've got 5, choose 1, which is just times by 5. All right, if you were to choose 3 B's, you'd have 8 B's and you're choosing 3 of them, right? So things will look pretty similar, but you're only choosing 2 A's. You're now choosing 3 B's, and you've got 1 C there. All right, if we choose 2 C's, right, so 2 A's, 8 choose 2 for B's, 5 choose 2 for C's, and we'll have 3 numbers, and we'll have to add them all up, right? Plus, plus. Okay. So let's see if I can remember all of that and put it into a calculator. We'll get the answer. Yeah, right. So I need that. I need this on. Okay. Let's do it. Let's get excited here. So we've got 3 A's would have been 6 A subjects, choose 3 of them. Arrow times. Let me go back. No, it won't. That's not going to work. I might just type it in the long way. Okay, 8, choose 2, arrow, times 5, choose 1. And we get 2,800. So that is a large number of choices, isn't it? Okay. Scenario 2 was that she chose 2 A subjects, 3 B subjects, and 1 C, making up the 6. 4,200 ways to do that. Scenario 3 was she chose 2 C's, 2 A's, and 2 B's. All right, also 4,200. When we come to get the total, we will need to add those three numbers up. So we've got this one, 2,800 plus 2 lots of 4,200 over 100,000, isn't it? 1,000, 100, what am I saying? Over 11,000. We've got 11,200. Words are failing me here due to the excitement of this scenario. I don't know how the school is supposed to deal with all these choices. Look at that, 11,200 different ways to choose those subjects. So hopefully that was clear. Let's write the answer in. So from memory, we had 2,800 there, we had 4,200 there, and we added it all up and we got 11,000. Come on, brain, you can do this. 200 different ways. Now, what I want you to consider is this. What I want you to consider is, why can't you do this? It's another why. Why couldn't we have done this? There's the 6 subjects. I think it's helpful to draw this out. You don't have to do that, by the way. So I often draw out my 6 spaces, but perfectly fine to go straight to the combinations. Obviously, you need to show some working out if you're in a test. Or equivalence. There's 1C. So I could say this is 6 choose 2. This is 8 choose 2. This is 5 choose 1. And then here I can choose from any subject. Now, all up, how many subjects are there? I've got 14 plus 5, 19. So 19. I've chosen 5. I've got 14 left. 14 choose 1. Doesn't work. Why not? This, this one could be A, B, or C. Right? A, B, or C. You had 14 left. I think some of you instinctively would try and do it in one hit. Right. Now, I think the explanation, it's probably best if we focus in on a option. Right? How is that? If I chose A, let's say we chose A as our last subject. Right? We'd be saying that we have a choice of 2 A's there, right? And we're going to put an A here at the end. How many A's are left? 4 choose 1. Wrong again. Still not going to work. I won't get 2,800 if I do that. I'll get a larger number. Now, the reason is you have to group all your A's together. The reason is in the formula. Right? We've got this is our combinations formula. We've explained it in class. What is the part of the formula that we need to account for the fact that order doesn't matter? It's here. Order doesn't matter. We have to divide by what? Well, if we're choosing 3 A's, we have to divide by 6. Why? Because there's 6 ways to order 3 things. Right? 6 ways. Right, now here, if I'm dividing, I've got a 2, the calculator's going to divide that by 2. It's going to divide this by 1. It's not going to divide it by 6, right, to cover all the A's. So you end up with a higher number. So if you stop and think about what the formula is and what it can and can't do, this will make sense. you have to group all your A's together. Otherwise, you're not accounting for all the different ways that you can order A's. I mean, we could maybe simplify this whole discussion and just think of, imagine I tried to treat the A's like this. Imagine I tried to think, let's choose 3 A's separately. We'll do 6, choose 1. We'll do 5, choose 1. And then we'll do 4, choose 1. What have I done now? I've actually made permutations. I didn't mean to change colour there. What I've actually got is 6 times 5 times 4, which is permutations. It's not combinations at all. Permutations. All right, so A's, B's, C's have to be grouped if the formula is going to successfully account for the fact that order doesn't matter. Okay, so that's an interesting one, and you can think about that in a bit more detail. Okay, thank you.